Good afternoon. My name is Lynn Fuchs. I'm a professor at Vanderbilt University, and I'm an Institute Fellow at the American Institutes for Research. This afternoon, I'm going to talk about the What Works Clearinghouse Practice Guide, and I'm going to provide an overview of the 6 recommendations that were provided in this 2021 practice guide. And on this next slide, that the title says Assisting Students Struggling with Mathematics, Interventions in the Elementary Grades. In this practice guide, the word intervention refers to instruction that's most typically provided as part of high dosage tutoring or as part of small group intervention within the school's prevention system, like multi-tiered systems of support or responsiveness to intervention. And in this practice guide, struggling learners refers to students who have ongoing difficulty learning mathematics and who require supports that are supplemental to the classroom's core program in order to make strong practice. So you see on the next slide, the individuals who served as panel members for this practice guide and came to consensus on the 6 recommendations that are included. I'm going to talk today about all 6 of these recommendations, but my emphasis in this session will be recommendations 5 and 6. This is because recommendation 5, which addresses word problems, includes instructional methods that are unfamiliar to some teachers, and because recommendation 6, which addresses timed activities, can be controversial to some educators. To provide greater emphasis on recommendations 5 and 6, I'll address the first 4 recommendations more quickly. Before I move on to recommendation 1, note that the evidence level for all of these 6 recommendations is strong. Strong evidence means that there's consistent evidence that meets What Works Clearinghouse standards, and that indicates that the practice improves outcomes for a diverse student population. So recommendation 1 is for teachers to provide systematic instruction during intervention. Systematic instruction means that teachers ensure students have necessary foundational skills for the topic they're addressing, that they sequence math topics so they build incrementally. They make sure that students see connections between the math topics, and they include lessons that are focused on the smaller tasks that are needed to solve more complex problem types before they introduce the complex problem type. With systematic instruction, teachers provide visual and verbal supports when introducing new concepts or procedures. This includes gestures, concrete or semi-concrete representations, as well as accessible or easy numbers. So students don't have to deal with large numbers when new ideas or procedures are being introduced. And teachers ask probing questions to identify student misconceptions, and they correct those misconceptions early to prevent enduring difficulties. Here's an example of one teacher's idea for connecting new ideas and procedures to existing knowledge when she introduces division. So this might be at 3rd grade, simple division, 24 divided by 6. The teacher reviewed previous material on fact families for multiplication using easy numbers. And there you see representations for 4 times 6 and for 6 times 4. The teacher explained how the problem can be solved by repeatedly subtracting groups of 6 from 24. So the teacher is connecting subtraction to division. She represents that in the way shown on this slide, and she connects the division problem to the representation of the multiplication fact families. Recommendation 2 is to teach a clear and concise mathematical language and to support students' use of that language to help them effectively communicate their understanding of mathematical ideas. When teaching mathematical language, teachers introduce new math vocabulary in the context of math instruction. So it's not done in isolation, but as part of the math lesson. The teacher uses student-friendly definitions with familiar math words. The teacher links new vocabulary to a variety of examples, including concrete or semi-concrete representations. The teacher uses clear, concise, and correct mathematical language throughout the lesson, not just when introducing the new vocabulary. And the teacher demonstrates how to solve problems, model precise mathematical language to explain their own thinking, and they have students provide verbal and written explanations of math concepts to help consolidate the students' mathematical language. And some schools create a list of mathematical terminology that strategically becomes more sophisticated with each grade so that there's consistency within grade levels and across grade levels in terms of the language that's being used. So here we see a graphic organizer that depicts a student-friendly definition, characteristics, examples, and non-examples for the term unit fraction. Unit fraction is a term that could be introduced in second grade, but definitely by third grade. And here we see the definition. A unit fraction is when the numerator is 1 and the denominator represents the number of the equal-sized parts in the whole. The characteristics of a unit fraction is that the numerator is always 1. The fraction represents one part of the whole. And the unit fraction is used as a unit of measure for that whole. And you see a unit fraction at the bottom left represented in terms of part-whole understanding and shown on the number line. And then you see the part-whole and number line representation of a non-example, a non-unit fraction, 3/4. Recommendation 3 is to use a well-chosen set of concrete and semi-concrete representations to support students' learning of mathematical ideas and concepts. When contextualizing explanations and demonstrations with representations, teachers select concrete and semi-concrete representations that effectively do a good job of representing that concept or procedure. And they connect those representations to the abstract symbolic, that is the numeric representation. So they make the connections between the concrete and semi-concrete representations to the number system. And they provide many meaningful opportunities for students to use a variety of representations. And they revisit concrete and semi-concrete representations periodically to reinforce and deepen understanding of mathematical ideas. And here we see an example of connecting concrete, semi-concrete, and abstract representations for simple addition. So the symbolic representation is at the top. The number 5 plus the number 4 equals, we know that's 9. We see that as it's worked out on the bottom of the slide. And it's represented with actual blocks, not pictures of blocks, for the concrete representation. And then the colored circles represent semi-concretely the two parts that are being joined to form the whole. The fourth recommendation is also a representation. It concerns a representation called the number line. And the recommendation is to use the number line to facilitate the learning of mathematical concepts and procedures, which is important for supporting advanced mathematics learning. What you see here is a number line that has a lot of different types of numbers on it. Using the number line as a major representation of number magnitude creates a platform for helping students build a unified conceptualization of a number system that can address whole numbers, fractions, decimals, and other types of number like the ones you see on this number line. At kindergarten through second grade, we're generally using the number line to represent magnitude of whole numbers. Here you see a number path, which is connected to a number line by which students can compare the relative magnitude of whole numbers. Beginning in the third grade, we use number lines to help students understand that fractions are numbers with magnitudes that can also be placed on a number line. And here you see different examples of number lines that show 0, 1, as well as fractions. But number lines can also be used to support student understanding of the concepts that underlie operations. And on the left, you see the number line being used to help students understand addition and subtraction. And on the right, we see the same in terms of simple multiplication that would be introduced in third grade, 3 groups of 1/2. The number line shows how that quantity and operation are represented on the number line. So this brings us to recommendation 5, word problems. And the recommendation is to provide deliberate instruction on word problems to deepen students' mathematical understanding and support their ability to apply mathematical ideas. So I'm going to talk about several different principles for teaching word problems. And as in recommendation 5, which is focused on word problems, there's a lot more information in the What Works Clearinghouse Practice Guide, which you can download using the title that you saw on the second slide of this talk. You'll have a lot more information there about this topic, as well as the first 4 topics that I covered quickly. So at grades kindergarten through third grade, students are taught to think about word problems in terms of problem types. And the main problem types through the primary grades are total, where 2 parts are being brought together to form a whole. Difference word problems, where 2 magnitudes are being compared to find the difference between those magnitudes. And change word problems, where there's a start amount, something happens to change that quantity, and then there's a new end amount. And the validated procedures for teaching word problems, again, students are going to be taught to think about word problems in terms of word problem types, and the teacher will teach 1 problem type at a time. And when the teacher introduces a new problem type, the teacher begins with an intact story, no missing quantity. And there's discussion about the mathematical event that's central to that word problem type, while stories are being presented. And then the teacher introduces a word problem that actually has a missing quantity for that problem type. And the students compare the intact story to the word problem with the missing quantity to understand the gestalt or gist of the mathematical event for that problem type. And the teacher, in using this word problem type and discussing the ideas behind it, uses role playing with children, acting out scenarios. She uses gestures and representations to help children visualize and understand that problem type, and also to find relevant information for solving word problems. So for each word problem type, the teacher teaches a solution strategy, and she introduces that solution strategy using systematic instruction with a worked example. The teacher models the solution strategy while explaining what she's thinking as she identifies the problem's problem type, as she thinks aloud about finding the relevant information needed to solve the problem, and then how she executes her solution strategy to actually derive the answer to the word problem. And she provides the students with a graphic representation, which helps them identify and organize the relevant information that's provided in the word problem, which they need to find their solution. So here you see an example of a change problem. Remember, I told you a change problem has a start amount. Something happens to change that start amount, and then there's an ending amount. So here the word problem, change problem, is Selena had some cookies. Then she baked 12 more cookies. Now Selena has 16 cookies. How many cookies did Selena have to begin with? This graphic organizer helps children understand the problem type and organize their thinking as they're attacking this word problem. They think about and identify the ideas that it is the starting amount that's missing in this problem. We're trying to figure out how many cookies Selena had to begin with. Selena cooked 12 more cookies, and she ended up with 16. She plugs those numbers into her visual representation of the problem. And then she transitions to a number sentence. She's identified this is a change problem. She knows the start amount is missing. She's identified the change amount as 12, and she's identified the end amount as 16. She uses her change number sentence to generate the number sentence representing this word problem, and she solves for her answer, which is 4 cookies. Notice that the problem type involves addition, but the student is subtracting to find the answer because it's the starting amount that's missing. Now, this is finding missing quantities in any slot of a number sentence is part of the primary grade curriculum, even as early as first grade. So this approach to teaching word problem solving lends itself to the curricular objectives embedded in the curriculum. Another principle for teaching word problems is to teach vocabulary and language that's commonly used within the problem type. So before teaching the problem type, the teacher identifies the vocabulary that's central to the mathematical event in that problem type. And the teacher teaches that vocabulary in the context of word problems, again, not in isolation. For example, many students don't recognize the difference between the words than and then, which are important in the context of word problems. When teaching the change word problem type, the teacher teaches and emphasizes the word then, and the teacher helps students distinguish between the meaning and spelling of the words then and then as part of her discussion of the term then. And when teaching difference problems, where we have two quantities that are being compared to find a difference, the teacher emphasizes the word than instead of then and helps students distinguish between the meaning and spelling of than versus then. Now, an important idea when you're teaching vocabulary in the context of word problems is do not teach vocabulary as keywords that are linked to operations. So a lot of teachers will teach the keyword more, and they will tell students that the word more means to add. This kind of use of keywords doesn't work, okay? Because the word more sometimes in the context of a word problem sometimes means to add. It sometimes means to subtract. It can even mean multiply or divide. So here we have the same word problem that we've been talking about concerning Selena's cookies. And if the child has been taught that the word more means to add, many children won't even bother reading that word problem. They see the word more, they pull out the two numbers and they add them, and that gives you the wrong answer of 28. Instead of doing that, instead teach children to read and listen to the entire problem. And the children should, after they read or listen to and think about the word problem, they restate the gist of the story in their own words. And the first thing they do is identify the word problem type. And understanding the vocabulary associated with that problem types helps children do this. So you see these words highlighted in blue on the slide. Then, now, begin with. These are important vocabulary words in the context of the change word problem type. They're central to the word problem type because they all involve the passage of time, which is part of the change scenario. It's okay to teach children vocabulary in the context of word problems in connection with identifying the problem type. But remember, the problem type doesn't tell you whether to add or subtract. You have to put together all the information in that word problem, all the relevant information to figure out whether you're going to add or subtract to find the answer. Another important principle for word problems is to gradually expand children's understanding of the word problem type by varying word problem features. And this includes adding irrelevant information, including irrelevant numbers to word problems, using additional pronouns instead of repeating the word Selena over and over again, use pronouns, which makes the problem harder. Presenting relevant information in graphs, not providing the label in the question sentence, and requiring a multiple choice format. And the other important principle to remember is as you sequentially teach different problem types, remember in the primary grades we have total problems or change problems and difference problems. You need to keep mixing all previously taught problem types on practice sheets, which helps children distinguish between the problem types and helps them maintain previously learned solution strategies for different problem types and helps them become more flexible problem solvers. So the sixth recommendation in the What Works Clearinghouse Practice Guide is to regularly include timed activities as one way to build students' fluency in mathematics. So I'm going to again here talk about several important principles for using timed activities. And the first is to strategically select fluency building activities. Not every mathematical topic you teach is appropriate for fluency building. When you're teaching complex topics with complex strategies that involve multiple steps, it makes sense to identify the smaller required skills that are embedded in the more complex strategy, and to select a skill that will support strong performance on the more complex strategy. So let's say that we're teaching benchmarking with 1/2 to estimate the placement of fractions on a 0 to 1 number line, which is a grade 3 math competency. An example skill that you could teach for fluency building to help students with benchmarking activities is fractions equivalent to 1/2. So in other words, students develop fluency knowing what equivalent fractions to 1/2 are. 1/2, 2/4, 3/6, all of these fractions have different denominators, but they're all equivalent to 1/2. That helps students benchmark fractions to 1/2 on a number line. And be sure students are already competent in correctly executing the efficient strategy for finding an answer to the skill you're going to build fluency on. So an example, in 1/2, the denominator is always 2 times the numerator. You can talk about why that's the case as you teach it, and then that will help students with a strategy. If you have 3 in the numerator, then you're going to have 6 in the denominator for 1/2. If you have 8 in the denominator, then 4/8 is going to be 1/2 with the denominator of 8. So you build fluency on skills, small skills that will help students as they are working on more complex skills. And to build fluency, you want to conduct practice in ways that supports accurate and quick responding. So when a student comes to an item and it's a fluency building activity, timed activity, they want to respond quickly. They look at the item and they say to themselves, do I know this answer? If they're confident, they say it. They know it automatically. But if they don't, if they're not confident about what the answer is from just knowing it, they have to use a known strategy that they've been taught. And you want to supervise fluency practice activities synchronously so that you can immediately correct errors. So when a student makes an error, that error needs to be self-corrected by the student using the known efficient strategy that you've taught. Don't let students practice incorrect answers during fluency building activities. And you might say, well, how can I do that? How can I do immediate corrections? This can be done with students working in small groups together or working in pairs. And you teach them a procedure, an activity for doing the fluency building activity together. And you make sure that that involves students stopping each other when they make an error and students constructively helping each other correct that error. And over time, students will be building their fluency because they're practicing correct answers in a timed activity. And encourage and motivate students to work hard by having them chart their progress and set goals. And the last slide talks about applying these principles when building math fact fluency. And I'll let you look at that last slide on your own so that we have time to address questions that you might have. Well, I hope everybody enjoyed the talk, and I'm happy to answer whatever questions you may have. So please enter them into the chat so I can take a look and answer them. So I see one comment in the chat, and in the absence of questions, I'll just encourage everyone to go to the practice guide. The 2021 What Works Clearinghouse Practice Guide is a great resource. It has a lot of example materials for you to study up on and try to implement with your students. So there's a question here about timed fluency, and people always have a lot of questions about that because it's important, as the question Lauren is asking here suggests, that students practice to build fluency once they have the strategies that are required, that they require in order to generate correct responses. We don't want children guessing during fluency activities, and we don't want them generating incorrect responses. We don't want children to be practicing incorrect answers because they haven't yet mastered strategies for generating the correct strategies. We want them to understand what they're being asked to do and have solution strategies that are productive for them. There are interesting ways to support students' fluency practice, timed fluency activities in the practice guide that are structured in a way that permits them to practice correct responses. So I appreciate you being part of today's session. And if you have any remaining, so you can get, Tracy's asking, where do I find the practice guide? The practice guide is online. It's very easy because it's to find. It's a very frequently accessed resource. So if you go in and put in 2021 practice guide, struggling learners, it will come right up. And there's lots of good information in the practice guide for people who are creating their own interventions. So in the practice guide, struggling learners are children who have a history of being identified through universal screening as having math difficulty, and often, but not always, receiving math focus within the school's MTSS system. So there's a question here about how to work with State Department people when there's legislation for struggling learners, but that's not defined. And I think that the practice guide will give you enough structure to help you contact and speak knowledgeably with your State Department people. I'm wondering if the producers have some idea where these slides will be posted, slides from the conference generally. Somebody's asking about that. So if somebody in the studio chat provides that to me, I'll get it to the audience. And just to be sure I was clear, the practice guide is free. There's no charge for it. And if you Google, like I said, 2021, What Works Clearinghouse Practice Guide, Struggling Learners, you'll be able to access a link and download the practice guide. Also, you can contact me if you want to request my slides, because I can't easily put that link into the resource section for you. So my email is lynn.fuchs@vanderbilt.edu. So I'll just begin to close out the session. I thank you for attending. Feel free, if you want the slides, it will be easier for me to just respond to an email with the slides attached. And thanks for your interest in this topic, and I hope that the rest of the meeting is productive and helpful to you. So thanks for coming.